Hi students, in this lesson we are going to discuss about binary tree traversal, inorder, preorder and postorder, non-recursive traversal using stack. We are using stack for non-recursive traversal of binary tree. So let's start. First, inorder traversal. So this is the step to do inorder traversal non-recursively using stack. The first step is create an empty stack S. We are using a stack data structure with the name S. Initialized current node as root. We are starting with our root node. That is our current node. Okay. So current equal to root. The F is the current node now. Then push the current node to S and set current equal to current left. Push the current node to S means we want to push F to S. Then set current equal to current left. Now our current is current left. So which one is the left child of F? B. Now the current is B until current is null. So we are repeating that step until current is null. So now B is there. B is not null. We want to push B also. Then the left of B is A. So we want to push A also. Then left of A, that is the left child of A is null. So we are stop this step 3. Okay. Then after the current is null, we want to do the fourth step. If current is null and stack is non-empty, okay, then pop the top item from the stack. We want to pop the top item from the stack. So our inorder expression. So our fourth step is starting with pop the top item from the stack. So we are popping A from the stack. So this is our top of the stack. So A, then print the popped item. Print the popped item means we are printing A. Then set current equal to popped item right. Okay. Popped and printed A. So which one is the right of A? There is no right of A. If it is there, go to step 3 again. Okay. Now also our current equal to null because right of A is also null. Is it? Because no right child for our A. Now also our current value is null. Then we are repeating this. If the current is null, we are repeating this. So pop the top item from the stack. Now the popped item is, now the top of the stack is B. So we are popping B and printed. After that, set current equal to popped item right. Okay. Current equal to popped item right means, so B, right of B is equal to D. So right of B, right child of B is D. Now the current is equal to D. So D is not null. Then we want to go to step 3. Push the current. So step 3 is push the current node to S. So our current node is now D. We want to push that into our stack. We have already popped and printed A, B and C. So we want to erase from it stack. Okay. Now we want to push D to here. Okay. So D, then we are repeating which one is the current equal to left of D. So left of D is C is now current node. So we want to push C into our stack. Now again left of C. Here left of C equal to null. Okay, if current is equal to null, we want to go to our step 4. If current is null and stack is non-empty, then pop the top item. So which one is our top item? C. So we are popped and printed C here. Then set current equal to popped item right. Current equal to popped item right. There is no right child for C. No. So we don't want to go to step 3. Okay. Here also here the current is null. If current is null, again we want to pop other top element. So this is D. We want to pop then printed D. Okay. Then we want to set the current equal to popped item right. Current was null. Then we want to set current equal to popped item right. Popped item is D. Right of D equal to E. Then go to step 3. Go to step 3 means push the current node to S. Push the current node to S means we want to push heat to here and set current equal to current left. The current left means it does not have a left child. Now the current became null. If current equal to null, we want to do the fourth step. Pop the top item from the stack. Which one is the top item? E. We want to pop and printed the topped item from the stack. Then we want to set current equal to popped item right. Which one is the popped item right? E. Right of E is null. Again Current is null. If current is null, we want to do again. Okay. Now we are popping and printing F now. Okay. F. Okay. Now the stack is empty. Okay. Now we want to do like this. If current is again null, pop the top item from the stack. Now we are popped and printed F, and we want to set current equal to popped item right. Which one is popped item right? F of right equal to G. Okay. So if G is not null, we are going to the step 3, push the current node to S. We are pushing G to S. Then set current equal to current left. Which one is current G? G left is null. Okay. If current is null, now the current is null. If current is null, we want to do fourth step, pop the top item from the stack. We are popping G and printed from the stack. Then current equal to popped item right. Which one is popped? Right child of G, I. Okay, now the current equal to I. If push the current node to S, and so we are going back to the step 3, push the current node to S. Which one is current node? I to S, and current equal to current left. So left of I is H. Now the current equal to H. Again we want to push H into our stack. Then current equal to current left. So current equal to current left means there is no left child to H. So current now became null. When current is null, we want to do this. Pop the top item from the stack. We are popping H first. Then set current equal to popped item right. There is no right child. Again we are, when we go to step 3, current is null. So we are going to, if the current is null, we are popping other item. So I, we are popped and print I. There is no right child of I also. If there is a right child, we want to push again back to stack. Okay. Now stack became also empty. We already popped H, I and G. So stack is empty. So if current is null and stack is empty, then we are done the inorder traversal. So our inorder traversal is A, B, C, D, E, F, G, H, I. When we are checking that with the trick, easy trick, we are traveling down A, then down B, then down C, then down D, E, F, then again G, H, I. Okay. So this is the inorder traversal using stack. Next, preorder traversal. Preorder traversal is visit the root node first, then left child, and then right child. Is it? Create an empty stack S and push root node to stack. Create an empty stack S. Then which one is our root node? F. So we are pushing F to stack first. Okay. Then repeat the following while S is not empty. Then we are going to step 2. Then pop an item from the stack and print it. So only one item is there in the stack. So we want to popped and printed F. Then, so we are already popped and printed F. Push right child of popped item to stack. So we want to do the right. We are pushing right child first. Then push left child of popped item to stack. Right child first and then left child. Left child is B. Okay. Again we are repeating. S is not empty now also. So again we are repeating. Now we want to pop and print B. Now there is no B also here. When we are popping and printing, we want to push the right child and left child of that popped item. So we want to push right child first. Right of B is D and left of B is A. Again we are repeating. So top of the stack contains A. So pop an item from the stack and print it. We want to print A. Again we are printing A. We are popping A. After popping A, we want to push right child and left child of A into stack, but there is no right child and left child again. So again we are repeating, popping top element from the stack D. When we are doing popping and printing D, we want to push right child of D, E, and left child of D, C. Again we are repeating, top of the stack contains C. We want to pop and print C. If we are popping and printing C, we want to push right child and left child, but there is no right child and left child of C. Again the top of stack contains E. So we want to pop and print E also. E also does not have right child of left child. Okay. So lots of pop operation finished. So these all are we are already popped and printed and also okay. So only G is the okay. So we were here. Then after that we want to pop G also. Popped and print G. So we want to pop G. When G is the when we are popping G, we want to push the right child of G I here and the left child, but there is no left child. So again repeating, we are popping I and print I. When we are doing that, we want to push the right child first, then left child, but there is no right child of I. Then we want to do H here. We want to push H here. So again we are repeating the same step. We want to pop and print H. The stackers contains nothing. So we are repeating this step until stack is empty. Okay. So stack became empty. Then when we are going back to our expression, it is our preorder traversal F, B, A, D, C, E, G, I, H. Our easy trick is to travel and consider the left side. Is it F, B, A, D, C, E, G, I, H. Okay. So this is a postorder traversal algorithm. Start from the root and call it as PTR or current. Okay. So now we are starting from PTR. Our PTR is starting from F. Okay. Push PTR onto the stack. This is our stack named as pushing F into our stack. Okay. If PTR is not null. If PTR has a right child R, then push minus R onto the stack. Then when we are pushing F, we want to consider the right child first. If it is a right child, then we are pushing minus G into stack, not G, minus G into our stack. Okay, then move to the left of PTR. Then we are going to left of PTR, repeat step 2. So now our PTR equal to B. Now our PTR is B. B means push PTR onto the stack. We are pushing B to the stack and then we are considering the right child first. So minus D. We are pushing minus D. Move to the left of our PTR. So now it is left of PTR as our PTR was B. So we are considering A now. A. So push PTR. So again we are repeating step 2. A. Now our PTR equal to A. Then we are pushing that into our stack. Then we are considering the right of A. There is no right of A. Then we are considering move to left of PTR. There is no left part of A also. If it is there, then it is step 2. If when we are moving to so PTR, now PTR become left of PTR. Is it? Okay, move to left of PTR means our PTR now became left of PTR. So the PTR is null now because A does not have a left child. If PTR is null, we are starting or we are looking back to our stack. Then pop and possess positive element from the stack and set as PTR. Okay, pop and if PTR is null, pop and process. So we are starting from A. Okay, positive element. If we want to, so we already popped A and printed. Top of stack contains minus value. If it is a negative node is popped, our step is we are setting our PTR equal to that node. Okay, minus D means PTR equal to D. Then set PTR equal to that D. Okay, PTR equal to then go to step 2. Now we are here. We are here at the subtree of D. Okay, so we are already popped this and set as a PTR. Now our step is going to step 2. Push PTR onto the stack. So again we are pushing but not. So this is D is our node. Before it is D is the right child of our B. So minus D we had pushed, but now we are pushing D. Then D has a right child. So we are pushing minus E. Then we are going back to C. PTR equal to C. Now we are pushing C also. C does not have a right child and also does not have a left child. Now the PTR became null. Okay. If PTR is null, pop and process positive element from the stack. So which one is a positive element? C is a positive element. Now became it is our top of stack contains minus. So if minus value is contained, we want to do step 6. Okay, we have already popped. See, I have erased all the popped element from the stack. Then so now the top of the stack contains minus E. If it is there, we want to set PTR equal to E and go to step 2. So what is step 2 saying? Push PTR onto the stack. So we have already popped minus E, and so now we want to push E. Then if E has a right child, we want to push that minus R onto the stack, but no. If he has a right of E is there, then also we want to repeat step 2, but no. Then we are going to step 5. If PTR is null, now PTR is null because there is no right of child and right of E and left of E, then PTR is null now. If PTR is null, pop and process positive element from stack. So we want to pop E and process E. Okay. Now again the top of stack contains D, positive elements. We are doing again the positive element. So we are doing this also. So we are already popped this. Okay. Now our top of stack is minus G. If minus G is there, we want to set our PTR equal to G and push that PTR to back to our stack. That is step 2. Okay. Then if PTR has a right child, we want to do this minus I, then we are going back. So if left child is there, we want to go to that. Our PTR is now the left of G, but there is no left of G, so our PTR again became null. If PTR is null, pop and process positive element from stack. But if positive element runs, if the negative node is popped, so top of the stack is negative. If negative node is popped, we want to set the PTR equal to that node I and doing the step 2. If the right of PTR is there, we want to push minus R, but there is no right of I. Left of I is there. Now our PTR is equal to H. So we want to push that. So if minus I is there means we want to push going to step 2 and we are push back I into our stack and we are going to the right of I. Right of I is also null. So we are not pushing. Then we are nothing to push and left of child is H. So now PTR equal to H. After PTR equal to H, we are pushing H also to our stack. Now PTR become left of H's, that is null. If PTR became null, we are here at the step 5 and 6. We are, if the positive elements, we want to pop and process. So yes, positive element H, then positive element I, then another positive element G, then another positive element F. Okay, so this is our postorder traversal. A, we are considering the right side. Is it when we are traveling? D first, then C, then E, D, B, H, I, G, F. So this is the postorder traversal of this particular binary tree using stack. Thank you for watching.